something much more readable soon. But I guess we should at least look at what maybe and then will do for us. So maybe and then chain together many computations that may fail is helpful to see the definition. So yeah, let's read this on here. Home package. Go into the core. Let's look for maybe. All right. And then. So we have some maybe. That's our maybe tab drag. And we want to turn into something else with maybe. Continue with the callback if things are going well. Okay, that might be a good idea. So where should we start this then? I'm going to write it down here just to see. Maybe and then tab by index. So if we pass this tab index and all that tabs, So it seems like it should be chaining up at the top, but then I'm not sure how to get out tab index. This is coming from, we started with maybe down map. We wanted to do view maybe so view dragging tab. We're just deciding whether or not we're going to show it. So if our maybe is that tab drag, and then we'll do something with that. So yeah, if we're writing a function view show dragging tab, and that one takes definitely a tab drag. Any model pass in as well. And that's what's happening here. So let's just do right now view show dragging tab, model tab drag. Let's comment these two lines out for now as I break this up. Tab index, yeah. Okay, this compiles, cool, and it's still showing. So, now let's see if we can make this even nicer. We have view show dragging tab, pass it the model, we should get back this, and then if all goes well is what and then is doing, we're going to call this. So we shouldn't have to match this stuff. Yeah, so it looks like view dragging tab is, because this returns a maybe. So if we do that, then we can chain and say, and then once we've gotten the tab by index, we'll just do view dragging tab, and that'll pass the tab. Let's see if that is true. So this would be pretty cool if this is how this works. I'm still learning a little bit here, which is why I'm not speaking as much or as confidently. You show getting tab. So actually this doesn't need to. We'll keep this here as safety, but it looks like this I don't need to do. This first one I just need to do tab index. Alright. Then yeah, back to this. Keep doing this. Alright. Tab. The tab by index is passing tab drag. So return type here. Oh, I think it's reversed. That's right. So I think it's called with infix operators, which these will be removed very soon. Oh, yeah, okay. So now we have the right thing, but this is still maybe what we want to throw in. We don't actually need. Yeah, so this will give us text nothing. Can we get tab index? And this as well. I'm trying to think if we can just wrap this as well. Yeah, let's try that real quick, because we're just doing the same thing over again. And we will run maybe.map and take model.drag state, tab drag, and do something we want to do. I think it's view show. We want to call what on it? We want to extract the. Oh, okay, that might be a good idea. We want to call get tab index. Get tab by index. This index we can get by running dot tab index on tab drag. So so now that I've kind of collected my thoughts a bit, so we're taking the tab drag, that's a maybe. We're trying to extract tab index out of it. Then we're passing that to get tab by index, which can return a maybe. So because it's returning a maybe, we're saying, and then probably don't need to do this. If we've gotten something, then we're going to do the dragging tab. And otherwise, we're going to do a maybe that with default. And we're going to have that be like text node that's empty, come from the result of that. So we'll see if this works. Okay, yeah, so this needs our tabs. This is the only difficult thing is writing this function in here. So we grab the tab index. In fact, should this have console errors? No, it's all coming up in here. tab index is expecting an argument to be int, but it's a list of strings. So yeah, what was that function again? List of strings. Okay, so it's taking the first argument now. So if we just swap these, would we be all right? Yeah. And then expecting a maybe. Virtual download. Yeah, I want to see this work. We've already sunk enough time into it. And if someone, if Ilya, if you wanted to help me out with this a little bit, I'm just going to return to what I was doing before because I want to get to the dragging aspect. And this is really just code cleanup once I can get my head around and then. So I'm going to comment this out for now. And I'm just going to do view show dragging tab. As a return, I'm passing view dragging tab to maybe.and then. The view dragging tab doesn't return maybe. Okay, hold on. View dragging tab. Oh, I see. So I want to return a maybe. Well, I think of what the behavior I want on this is. This is just the text node, perhaps. So it's really maybe view show dragging tab. That's what I want. Perhaps. Because this one's the one where it's just saying if it's viewing the dragging tab, then we're good. We don't need any of this logic, though. So this is returning what exactly? Getting the tab. So maybe, oh, okay. So this one's now taking a maybe. This is making sense now. This is taking a maybe tab. So maybe tab. And if it is just a tab, then we call this. Otherwise, we do that. Okay. Now it's saying we get maybe A, but the right argument is maybe string returns virtual download message. This is because it's supposed to be just. It is maybe string. This tab index. So get tab by index returns a maybe. Is that a problem? It seems to be it just wants an actual type, a new type. So turn it down a bit with maybe that map. View dragging tab. With default. Text empty. First, maybe that map might need to be maybe.and then instead. It's a maybe string. So wait, Luke, are you saying that the maybe map, are you talking about this one being the first one? Maybe string. Message. Yeah, I can see that there's definitely, we have another chat message. Let's try out this solution real quick. All right. We got the model tab drag, and then we have maybe and then. We extract the tab index. We give the tab index, models tab, tab index. And then we pipe that to view show dragging tab. And then with the default of that text. So we've still got a maybe, we got nested maybes. Yeah, the definition of get tab by index is take some tabs, takes an index, that's a maybe. So this is a maybe, and then if it succeeds, grabbing the tab index from it, we would then get the tabs by the index. Okay, that makes sense to me. And then we map to view showing dragging tab. This makes sense in terms of a solution. I'm not seeing what's wrong though. So it's on this pipe. It seems like it's being, this is still keeping it wrapped as a maybe. Because if it wasn't, then it'd be fine. View show dragging tab has the wrong type. Oh, I see. So we're just going to be doing in this one to just view dragging tab. Oh, okay. There we go. Thanks so much. That's really cool. So I think if I'm going to try to explain it now that it makes more sense to me, it's that it's taking a maybe drag state and then saying, okay, if this function right in here succeeds, where we extract the tab index from the drag state, and then we call get tab by index, that returns a maybe. So now that we have this this maybe tab, which is the text, we're going to call map on it, saying, hey, we have this maybe text. We're going to assume that if we do have it, then we're going to view the dragging tab, which is no longer a maybe tab. No, it's definitely, yeah, we don't need this anymore. So now it's just calling view dragging tab where we have some string, show this HTML, and then with the default, provide just empty text. So that makes a lot more sense to me now. It's still pretty dense, but I think my problem was starting with this and seeing the data get worked through with each of these functions, apply through and then. It'll be nice when Elm18 has this as well. Clean this up a little bit. So thank you so much, both of you, and I'll commit from that because I don't want to lose that work. conditionally. Cool. All right, back to dragging. We will add a style here. And so style does an inline style, and it takes a list of tuples, and the tuple, the first position being what the what the CSS property is. So in this case, we're going to talk about top. We're going to talk about a value for top, and then a string value, and then we're also going to talk about left and a string value for left. Another thing that's important here is we want this positioning to be absolute, so that it can hover above other things. And then the top position, we want to be whatever the current position is. So we'll just pass an XY to here, and then we'll assume we get something like mouse.position passed in. That'll be the XY. And really we can just open that up, this mouse position record, and grab X and Y itself. So we'll have our top being the Y from the top, and the left being the X. And now we need to view dragging tab. We're going to need to pass in one other argument here, and that'll be the current position. So looks like this one is happening if, what's this one returning? It's getting a tab. Interesting. So this is a thing where it'd be nice to have that case expression, because now we have information about where the current position is. So trying to think if there's something smart I can do in this. So we have the drag, and then we're passing the tab. We could just return this in a tuple saying no, because it needs to be a maybe that we're mapping with. Let's just throw in the drag state for right now. We can fix this a little later. Sorry, not drag state. I keep saying that. Tab drag. So now that should be coming in, and it's not going to be as nice as that. It's actually going to be the tab drag. So this will be a bit redundant, but case tab drag. It's really going to be a maybe. Yeah, I'm curious on how to pass in information from each of those transformations that we need to keep, like when we extracted that tab index. Passing in multiple arguments like that. Not sure how to do that yet. And then just do this. So in here, we just carry back current. And we'll do current.y. And we'll do current.x. And apparently we didn't need that. We do need this, so we're going to throw in style here as well. Oh yeah, so these are integers right now, they need to be strings. So let's make a quick helper function where we also throw pixels in. So pixel will take some integer, and we will do toString on that int, and then we will add pixel to it. And then we just need to call that. Okay, cool. So now we have a dragging tab. Woohoo! we need to be able to drop it in reorder. So let's at least commit that. I'm not super happy with that. That may be unpacking again after we did all that work, but I'm just probably missing something. So we'll just say tab drags. Oh, tabs drags. All right, why not? Let's now try to get it to. Now we have to do actual business logic, which will be fun. Which will be taking that index and throwing it somewhere in the list where it didn't start. So in here, it's going to happen on the tab drag end that we need to insert it into a new place. So what I like to do is when I'm updating my model is just pipe it through various functions. So we're just going to call this drop tab, and we're going to drop it in somewhere else. So let's write drop tab. We'll take some model, and we'll also give it an XY. Okay, and then we want to throw in, we want to update tabs to like the new tabs that we'll define in this function. So let's so the first thing, I'll explain my algorithm a little bit and how I want to do this. So let's say we have the tabs 1, 2, 3, 4, 5, and 6. This way we have a lot of data to work with for when we have tabs to the left of it, to the right of it, of the start position. So I'll just do this. Cool. So let's say we have 1, 2, 3, 4, 5, 6, and this is the input. And the output will be, let's say we start with moving, let's say 3, and then we're going to drop it let's do I know so they're lined up. So we're going to drop 3 into, we'll move it right first. And we'll drop it into where 5 is. So let's move this, and we're going to put it where 5 is, so it should look like this. Okay, so that's going to be the first test case that we're going to write this code for. So all we have is a global mouse position, and then we also know everything about the tabs themselves. Let's make sure that, oh interesting, the tab comes up on right click as well. That's always fun. So does this have any like padding? Yeah, it's a little bit off, has some kind of margin. Yeah, there we go. There's a margin. So let's just eliminate that margin for now by going to our body, redefining body to have margin 0. Okay, so now things are, we don't have to assume any additional pixels or whatnot, and we can introduce that later. We'll add the margin back in. So all right, first thing we're going to do is find out what the difference in the x position is. So if we look at diff of x, or we can call that dx, that'll be whatever the end position is minus the start in both of their x's. We did not pass start and end into here, so let's actually do that. Start and end. And so how do we get that? It'd be nice to not have to unpack tab drag every time like this. So let's just pass tab drag in as an argument. because we already unpacked it in the subscriptions. So we look up here, we mashed it, we have tab drag. Let's just throw it in. This should make our code a little simpler. So now in our messages, we're also passing tab drag. All right, so for dragging, now we have tab drag. So we don't have to do this maybe map. We can just run set current on tab drag and call that just. And then here we can also pass. We get the new current, which is the XY. That's the most up-to-date thing from the subscription, the newest mouse position. But we also have tab drag here, and we'll assume that the start is tab drag dot start, or we can just grab start out of it. Okay. So now we have start, we have ends, we have a model. All right. Now we just need to define new tabs. So the next thing that we're going to do is start thinking about what the offset is from the nearest tab. So if I click, let's bring this back over here. So let's say I click here, then we want to know how far is this from here, because that'll mean like when we cross the threshold to go and drop into another tab. So offset from previous tab. That'll be whatever we start with, and we're gonna divide that. We're gonna find the remainder for each tab width. And then tab width, I believe we defined as 200 in the, no, 100. Okay. So yeah, we're assuming everything is constant size for now, as I said in the beginning. And then we want to look at the distance to the next tab, and that'd be the tab width minus that offset. So we have the offset from the previous tab, and now we have the distance to the next one, so offset from previous tab. So let's throw these on here. So what I'm talking about here is offset from previous tab is this distance, and distance to next tab is from here to here. So we're taking the tab width in total, and we're subtracting this offset piece. And then we're going to talk about, we need to find out which direction we're moving in to do things differently, because there will be different orders in the list where we drop in the new tab. So we're moving left if dx is greater than 0, if we're subtracting the end from the start. And we're going to be moving right if dx is less than 0. All right. And then, now that we know if we're moving left or right, we need a Boolean for like, did we cross over to the next tab, or did we cross to the previous tab? So let's go in the order of previous next. So crossed to previous tab will be the dx is greater than the offset from the previous tab. So yeah, if I've moved left greater than this distance, then I've crossed the previous one and crossed to the next tab. It's going to be if dx is greater than the distance next tab, except dx in this case, when we're going right, is negative. So let's just take the absolute value of that. And I believe this will be fine. Yeah. Then, now we need to actually calculate what our new tabs are. So we'll define new tabs here. We should have everything in scope that we need. So if we're moving left and we crossed to the previous tab, so in that case, this is when we're switching, when we're actually shifting tabs. Or, I'm not sure where the best place to throw this or is. So, or we're moving right and we crossed to the next tab, then we're going to shift tabs. And we're going to shift tabs, yeah, either left or right. And then else, we're just keeping tabs the same. It means we do not cross any threshold. So the tabs are exactly the same. What do we need to pass to shift tabs? We need to define shift tabs. We already have tabs, right? Or we have model. We have our model. Which, this is pretty cool. So if you unpack the model and say tabs, you can also put parentheses around it and say as model, so you can still refer to that entire record as something, in this case model, and then grab out the contents. So cool. Now we just need to define shift tabs. So shift tabs should be doing this operation here. And what do we need to pass the shift tabs? We probably need like the tab ID, the tab index, the one that we selected, and then the tabs themselves. We're unpacking that already, right? Yeah. Then we probably also need the tab we are shifting to. So this first argument will be like the end index, I guess. Or the new index, I guess. So new index is going to be end.x, where we end it, divided by the width of the tab. I think this would be integer division. Yeah, they're all ints. So yeah, we're taking the last one, we're dividing about how many widths there are, and that's going to be which index we're in. So shift tabs takes the it's going to take the new index, and then the selected, the tab that we started with. So yeah, we can call that selected index. Excuse me. And then the tabs themselves. So shift tabs, this is going to be an int, and another int, and this is going to be a list of strings, and this is strings. Cool. So we'll probably get to do some logic in here, so we're going to do a let block. I'm assuming it's not going to be in like one line. All right. So the idea I have in mind is that we do something like list.concat, where we are grabbing a bunch of like sublists of the final list and then putting them all together. So let's say like for this one, let's run through kind of the idea I had in mind. So in the first case, when we're trying to rebuild this list, we're taking all of the elements up until the thing I selected, right? So we're going to have 1 and 2, and we're going to add that list to the current selection that I have. So 3, but when we want output like for this 5, we actually don't want the selected thing yet. We want to add in 5 and 4, which is everything from it's everything from where we want to end up, and then more on top of that. Let me just think about that for a sec. Yeah, so it looks like Yeah, actually, this should be 5 and 4. I wrote this wrong. This should be 4 and 5. Because all I did was shift 3 into the position of where 5 is. I just wrote those backwards. That's why it was throwing me off. So we have 1, 2, and then we want to take everything up until where I'm going to drop it off. So we're looking at this range. Then we're going to look at this range. And then we're going to add our selected thing in. And then we're going to add anything to the end of the list, anything after the drop-off point, so after here on this first list. So that's kind of my idea for how we're going to move tabs. Now this will only apply going right, because we'll notice when I was thinking about it that if we go the other direction, this is going to need to come before these in this ordering. So right now we're going to assume we'll have this actually be called something like, this is shifting right, right? So let's call this shift right. We'll do that. So list.concat, and we're going to get each of these sublists. So we'll just call these what I was talking about up above in the little bit of pseudocode there. Well, not even code, but just the idea. So the tabs until first selection, the first index that comes up in order. And then after that we have our tabs between the first and second indices. And then we have our, okay, so yeah, so these are the tabs up until the first, and then these are the tabs between the first and second. But it's not entirely between, it's also including the second, but we'll just stay with that name. And then we have the rest of the tabs. And we also need to throw in the R selected tab. So because it went right, it's coming after the things that are between. So, and maybe there's a way to do this without having to have a separate shift right and shift left by including, excluding the things correctly. But this is how I've written out on my whiteboard before this. So we'll have tab index, oh, sorry, selected. So it's really just the selected index. And so we need to grab the tab for that. So selected tab. So let's assume all these things exist. And then now that we have that new list, we'll just say shift right for right now. So, okay, cool. Now we just need to fill in all these functions. So tabs until the first is going to need, shift right's going to need the first and the second indices. So I'm going to call that just, which one's the first one? That's going to be, if we're moving from the left to the right, the selected index is going to be the first one. Yeah, it comes up first, and then to the right is the second. So we're going to say selected index is the first, new index is the second one. So tabs until the first, we'll pass in first here. We'll just do list.take until the first, and all the tabs. So that's one down. Then we want to take the tabs between the first and second. So we want to pass that first and second. And for that, we're going to start with our tabs. And if I'm doing multiple things, I like to usually start with the data structure and then just pipe them down like I did with model. So we will drop everything from the first of the tabs. You need a +1. Yeah, because we're not including our selected thing. We're not including, in this case, we're not including 3. So we're going to drop that as well. And then we're going to do list.take, where we're doing second minus the first, since we've shifted over to the first, but now we're just going to take the sublist of that up until that second index. So these two operations should give us 4 and 5 here. I'd be shocked if this works the first time with me in numbers. It's not a good match. And then selected tab is just going to be, we're going to do list.take. We have the selected index, and then what's the case if it's not there, right? So we do list.head, just we drop. So this will be a maybe, and so that's the thing, is actually like case selected, maybe selected tab of just don't want this to ever return. We just want to return the tabs if it's not there. So in this case, it's just the selected tab. Then we're going to do our shifting, and if it's nothing, then we're just going to return tabs. So this is the maybe. In fact, this kind of makes sense just like this. We can do head, have this be a one-liner, rather than polluting up this part. Okay, so now we're saying if we get the head of everything up until the selected index, tabs, are we going to get the selected tab? If so, we're going to do our shifting. Otherwise, we're just going to return tabs. There's something went massively wrong. Tabs between first and second, we want to pass first and second. Selected tab, that gets passed in as well to selected tab. Cool. And then the rest of the tabs, let's build that function. Rest of tabs, it's going to need the second one that occurs, the second index. And we're going to do list.drop everything up until second. But we're also not going to include that one because we're replacing it with our selected one. So we're doing +1. And this will be on tabs. And we need to pass this second. Okay. So we just passed everything. Let's see if that works. Okay, I need something here. Tab index. Selected, right? So we want to know this from, this is the one, so we have new deck and we have the selected one, which is in our drag state, which we didn't pass to this. So maybe we should just pass the whole tab drag. So we have start, and then we have, do we call it tab index? I believe so. And then drop tab, we'll just pass drop drag tab, tab drag. I'm really bad at remembering tab drag. Okay. There's something wrong here. Select the tab. Doesn't like that. It's self-referential. I guess I'm using it again. Selected tab. Just call this selected. Interesting. Does shift right call this code again or something? Just call it selected. Okay, still doesn't like that. Yeah, what's all that about? Yeah, so I'm definitely selected index. Let's just keep this as tab. And then for this is definitely a tab. It's just not liking. I don't see how it's self-referential. Question mark is always nice. Am I trying to refer to this function somehow? I don't believe so. Maybe instead I can do, let's try this. So we have this dot head, and then we maybe dot map shift right. So we have the selected tab, maybe, but assuming that we do, we will just pass that in to shift right as the last argument. So selected index, new index, and then tab. And then we'll do maybe dot with defaults, just tabs. So shift right now takes this as the last argument. Oh, maybe I defined shift right too many times or something. No. You know what? On this tab, maybe it needs to get. I see. So it was the wrong type. In the concat takes takes several lists. In this case, 4. And selected tab was not a list; it was a string. So I had to make it a list of strings by adding that. But I believe that is getting to be a better error message in 18 as well. Could be wrong on that though. So anyways, we have our different things now. Don't know if this will be. I don't know what just happened. Let's try that again. Tab 1. Cool. It swapped. Awesome. Well, that's just a perfect instance of it worked once compiled. I believe we will mess this up if we go left. Yeah. So let's write a shift left. Shift left first and second, and then the same thing with selected tab. List.concat. What needs to change? Maybe we can make this better. So tabs until the first one first. Then we're going to look at probably switching the order of these. So now instead of selected tab coming next, coming third, it'll be selected tab here. And then now we'll put the tabs between first and second. First, second. And then we will also have the rest of the tabs with second. So that's mostly the same, except this one has this in a different order. So maybe we can squash these functions. But right now we'll start with this. And the other thing is we're always calling shift right. We need to find out under what cases we should shift right. So I think it's if the selected index, if the one that we're moving, is less than where we're going to drop it, that means that we're shifting right. And if it's greater, then that means we're going left. So how would we do that exactly? So let's just make another function called shift, which takes these two arguments and that tab, and we'll just do if selected index is less than the new index, then we will shift right with the selected index being the first argument and the new index being the second, and else we will shift left. Yeah, trying to think if there's any cases I'm missing. Okay, yeah, shifting left, we're going to do the new index and selected since they're in opposite order. And then I don't think this will work because tabs between first and second was doing this math with plus, assuming we're just swapping now a different, like if we look out here, we did the same thing. This is the case of, whoops. Okay, let's do moving 3 to here. So this was the case of shifting right, and let's make a shift left case where now we start on the 5 and drop it off at here. So we should get the 5 here, 4 stays the same, 3 goes there. Is that true? Start at 5, drop in there. No, that doesn't get swapped, it just gets moved up. I keep doing this. It's not a swap. Swap would be, in a way, easier. I think it would definitely be easier if we just use array, get, and set. So it just moves, shifts things over. That's right. So if we shift it left, now if we look at this, we take 1 to 2, because that's until the end position, and then we need to throw in the selected one. So that's why we did this right here first, because we have our selected one coming next. And then the range for the tabs between first and second needs to change, because in this one, if this is, let's change this algorithm, we need to have this just be 5, and then, so 1, 2, 5, and then we need 3 until, yeah, let's do 3 4s until then, and everything after. So rest stays the same. And so now you can see that on this range, it's going to be different because now it starts right where this one ends. Before we had these two, and then we we moved past the selected one, and we moved up to this. We had a +1, so we need to change this for this case. So maybe we call kind of a better name than tabs between first and second. Maybe we get that there's like only one time where tabs are between the indices, so we'll just say tabs between, and this one will be like on the shift right. This is the one I was working for shift right. So let's take this exact same function, and we'll make one for tabs between shift left. So now instead of adding that first, we took that away, and now it should be good. Except, is there anything else? I think that'll do it. It's just because we had to skip before. So this is tabs between shift left, and then tabs between shift right. So now let's check and see if our original case works. 3 to 5. I messed up that clicking behavior a little bit right there. Let's just try 1 to Okay, that's good. That looks right. Let me just refresh the page again and do the original 3 to 5. Cool, that looks good as well. And now let's refresh again and check and see 5 to 3. Ah, okay. That's a lot of extra tabs. What is wrong in my math? Let me think. So I don't think that the tabs until first needs to change. And I think I'm getting the shift right. So let's look at shift. Oh, I'm calling shift right every time. That would be why. So there. Let's try this again. Shift. Why are you not happy? It also expects the tab, yeah. What's the difference between these two? Oh, I forgot to pass tab as well. Very cool. Okay, let's see that this still works. Looks right. Looks right. And let's try shifting left 5 to 3. There we go. Awesome. Okay, so the concept of dragging tabs works, which is super fun. That time just flew by, didn't it? Especially with all that maybe work. Drag. So we're just going to document what these things are. This is going to be mouse.position. And we also have our model. And we're going to return a new model. Drop tab. Good. Cool. This looks to be in a decent enough place to commit. Drag and drop works both directions. Cool. This is fun to play with. So the next things we want to do to extend this are some animations. We obviously have like the idea of a preview. It looks like the position is a bit off because we're having the tab be like where the mouse position is. It should probably be the middle of the tab, I guess. We could do that pretty simply, I believe. If we go to the left right here, if we just add halfway, so if we say the current x is plus, how much was the horizontal width? 100, so plus 50. And this might be better with just like tab width divided by 2. That might be better. Order of operations, please do. Just be safe. And then for the y, we'll say tab width divided by, not tab width, but tab height divided by 2 as well. Alright, neither of those are defined anywhere at the top level, so let's just move this to the top level. Draw in some useful stuff. This probably belongs by the view, actually. These are all put into updating. Tab width and tab height. Our tab height is 50, I believe. Is that true? Yeah. Cool. So now, will that fix? Nope, didn't compile. Open up parens. This is to that, this is to that. Looks like we need to divide integers. Cool. Oh, that was wrong. Not plus, minus. Yeah, so now it looks like we're getting the middle of the tab. Not sure what design people think is the best thing for this, but yeah. The other problem is because this is on the beginning of the mouse drag, the clicking them to select the first feature we built doesn't really work. So we should find a way to like delay that, like when someone holds it down for more than 300 seconds or something. That would be good. So I'd say we add a list of tasks to do. I don't know how much longer I'll actually be coding today. Let's say we add a, I guess a readme would be nice. And we'll just say like to do make tabs draggable. The next thing we need is the ability to show like a preview, probably like preview drop zone. And then we also want to delay drag on mouse down for X seconds. What else is there? Like so we want to, and then I wanted to get to some animation, but I guess I was pretty ambitious to do try to do all that in one day, or in 2 hours, I guess. So animation, we also want that to work on. I was thinking something where like here's a tab, and at first they start like this, and then when you bring your mouse in between them, they like kind of spread apart like that, and maybe either they spread apart like a spacer gets bigger, or they shrink a little bit. But I think probably spreading apart is the better thing. So there's a spacer in here now that gets bigger. I think that would be pretty cool. But I think that I should break this up into maybe like 2 sessions. I think now that we have draggable tabs, this stuff is going to be possibly easier. And I need some time to look at animation. So thanks for everyone who joined. And I'll be pushing this up and posting in the chat afterwards somewhere. It'll probably be on my GitHub account. So my guess is that we'll be looking at GitHub. This is my GitHub username. Don't ask why it's still that. And draggable tabs. It's probably going to be the name. So, yeah, this is what we'll get to next time. We'll just say we add a to-do list and readme. All right, anyways, thanks for tuning in. Hopefully do this again next Saturday or something. And I'd love to see like any ideas people have. Feel free to like tweet at me or send me a message in the chat afterwards. I'd love to see any ideas for like animation. I think that there's some cool things out there, but I'm gonna do some research on it. So see ya, thanks again.